We're dealing with solving quadratic equations just by finding square roots. Today we're going to simplify radicals and then solve quadratic equations using the square root method. Sometimes the square root method is going to be your quickest route. We're going to talk about what do these equations look like if I wanted it. Sorry for the craziness, all right? I took this from somebody else, so it's nice and fun. All right. Simplest form of radicals. You guys already have this down, but I want to go through this one at a time. First off, an expression with radicals is in simplest form if and only if you've got no perfect square factors other than 1 in the radicand. So like the radicand, whenever I say radicand, stuff underneath the square root. So you still cannot have square root of 36 because we can simplify that to just a 6. Also, you can't have any fractions in a radicand. That's underneath a radical again. That's underneath a square root symbol. You can't have any fractions in a radicand. And you can't have any radicals in a denominator. These are like things for improper mathglish, right? Instead of improper English, this is math, whatever. Improperness, we don't want it. So let's just practice a little bit. Let's simplify these if you haven't done so already on your paper. So when we do the factor tree, we have a pair of 2's. That's also, so technically underneath the square root, we have a square root of 4. Wait, what's the square root of 4? Just a 2. So that's another reason why 2 becomes a leading coefficient and we're left with the square root of the other 2 numbers multiplied as the radicand. In the second problem, I'm going to multiply the radicands. I get the square root of 36, and wait a second, square root of 36 actually becomes a perfect 6. When you have a square root of a fraction, sometimes you can take the square root of the numerator and just divide it by the square root of the denominator. Sometimes when we look at a whole picture altogether, we get a little overwhelmed. But wait a second, let's just break it up. We can break it up as a square root of 81 over the square root of 121, giving us 9/11. Notice how after you take the square root of these numbers, there is no longer a square root symbol. Just make a note of that. First example. So in this, 4x squared minus 5 equals -1. Gotta wait for my technology to kick in. There we go. Add 5 to both sides. Most of you did that. And you got 4. Now, if I'm doing the square root method, that's why I'm concentrating on the square root method, so I'm going to do this the square root way. Wait a second, why would I choose the square root method? Let me go over that first. I notice in the problem, all I have for a variable is x squared. There's no linear term. Wait, linear term. Meaning there's no number with an x also in there. It's just an x squared. When we have this situation, square root method is going to be the quickest. So I try to get the square or the quadratic term by itself, divide both sides by 4. We got to take the square root because I'm in the solving process and I'm going to take the square root of both sides. I'm going to make sure I incorporate a positive or negative possibility. So x is equal to plus or minus 1. Notice how the square root symbol is away? We don't need it anymore. Once you complete the square root operation, you don't write it. We've got 12 minus 2y squared equals 4. I'm going to walk around, see what you guys have.
Is it 2 or 4?
It's going to be plus or minus 2. Here's why. So negative 2y squared equals negative 8. You divide by negative 2 on both sides, you get a positive 4. When you take the square root on both sides, I'll just put this in. When you take the square root on both sides, you should add in your plus or minus. Add in your plus or minus. If you forget that plus or minus come quiz day on Monday, if you forget that plus or minus symbol, it's points taken away. Points taken away. So answer y equals plus or minus 2. This means both positive and negative 2, if you plug them in, they will make this statement true. So p squared over 4 minus 3 equals 33. Very first step is to get rid of that minus 3. So you add 3 on both sides. Answers are now plus or minus 12. Just to recap, a solution to an equation makes this original equation true. So positive 12 and negative 12 both checked out. Last example, or no, second to the last example. I'm going to use the square root strategy because I have a perfect square on this side and a perfect square on this side. Let's take the square root immediately and add in the plus or minus. Where would we add in the plus or minus? Let me show you. So we take the square root on this side. It's here that we put the plus or minus. You don't want to put plus or minus on both sides because of this variable side. We don't really know what that's going to be. So don't put a plus or minus on both sides. Let's just put it in one spot. We're going to put it on this right side.
Why are you already putting in the plus or minus sign? Can you just put in 3?
So hold on. Question was, why are you putting in the plus or minus sign? Can't you just put a 3? You have to put plus or minus 3 there. You have to put the plus or minus symbol. You're going to see what happens whenever we get to an answer. So now after to take the square root, I'm just left with y plus 3 equals plus or minus 3. Subtract 3 on both sides. Here's what it looks like. I'm going to get 2 answers. One of my answers entails negative 3 plus 3. The other answer entails negative 3 minus 3. One of my solutions should be 0. The other solution should be negative 6. Without that plus or minus, I lose a solution. Whenever you solve an equation, you have to find all the possible solutions. Put a star on this one. You actually cannot immediately square root. And it's because of this leading coefficient. In order to immediately take a square root, you have to have a perfect square on one side and a perfect square on the other. The bad thing about this is this factor is not a perfect square. How can I get rid of this factor? So to get perfect squares on both sides, divide by 2. Now I'm left with x minus 3 quantity squared equals 4. Now because I have only perfect squares on both sides, let's do the square root method. So when we take the square root on both sides, let's add in that plus or minus, shall we? This is broken up into 3 plus 2, 3 minus 2. My 2 solutions become 5 and 2. Let me write that a little bit more clearer. Those are my solutions. So let's backtrack. This should be, we should have a 2 here. So that means technically this is a 1. So I should always check our answers. The only thing different here, I don't have a perfect square on either side yet. I got to get rid of this coefficient of a 4th. I could either divide by a 4th or multiply by the reciprocal. Let's just multiply by the reciprocal, shall we? Notice how I said square root method is very nice whenever you have perfect squares on both sides. It's also very nice when you don't have perfect squares on both sides, but this is definitely a perfect square. You want an expression being a perfect square because you can still attack it quickly. You can attack it quickly. Take the square root on both sides. See what happens. And then the last step is the only thing different. We're going to have b equals, we would add 8 to both sides, but this is what it looks like. 8 plus or minus 2 root 7. Because I can't add 8 with whatever 2 root 7 is, I actually leave it like this. This is a simplified form. This is the exact form. Now, let's say you were taking the ACT or SAT or ASVAB, whatever have you. If it asked for decimal approximation or round to the nearest tenth, then you would have to break it up and say 8 plus 2 root 7, put it in your calculator. But 9 times out of 10, the ACT will want you to stop here. Those are what the answers will look like.